Section 11.6, scatter plots. And we got a couple of vocabulary words. Make sure you get these into your notes. Those will be good words for your vocabulary quiz. But let's talk just a little bit. What are they talking about when we're talking about a scatter plot? These are a couple of examples of scatter plots. In other words, what we've done is we've measured something. So, for instance, in the example they were talking about, you measure a person's height to their arm span, and you get a pair of, or a set of coordinates, and you plot those. And so let's say that, for instance, we had done this with a graph like that, and we just get some different plots. So, or typically, in chemistry, there's a lot of times where we'll do an experiment, and we'll get some different things. So, for instance, we might be working with density, and we're going to be measuring mass and volume, and we're going to plot mass versus volume, and we're going to get a scatter plot of all this data that we picked. Because we just, maybe we did it 6 times, and so those are points that we're going to get on there. And that's a scatter plot when we just kind of do that. And you can see in this one that, in general, the direction of this graph is up and to the right. In other words, it has a positive slope, and so we would consider that to be a positive relationship. This particular graph looks like it's going down to the right, so that would be a negative slope, and that therefore it has a negative relationship. And then the last one, it looks like, man, there's no relationship whatsoever. It's just random. Maybe you just, you had something and it just has no pattern. And so that last one has no relationship whatsoever. Close that. Okay. All right, so let's take a look at this example here. It says, determine whether a scatter plot of the data for the hours traveled in a car and the distance traveled might show a positive, negative, or no relationship. So the first thing is kind of look at it. Can you draw a fairly, well, one, it would be a straight line, and maybe it wouldn't go through every point, but can you draw a line that's pretty close to all those points? And it looks like in this one, yes, definitely you can draw a line. Looks like you can even get it to go through every point. And so, yeah, there is a relationship. Since that hill, is going up as you go to the right, we call that a positive relationship. So this would be a positive relationship in this particular example. If we look at example 2, on the other hand, how would we draw a graph? I mean, what do I got? I got all kinds of stuff. I've got, that doesn't look good. I can go, I got everything. So, you know what? I'm going to say that this one has no relationship. And so they were doing a scatter plot for whether the month of the birth and your birth weight had any relationship. And no, there isn't anything between what month you're born in and how much you're going to weigh when you're born. No, nothing there. Okay, let's take a look at this next thing. And it talks about a best fit line. And this is a very good concept. We use this in chemistry. We talk about this in chemistry. Because, when you do an experiment in chemistry, things don't come out perfect. You've got some error. Maybe you didn't read it quite right. And so you don't get a perfect line. And this is what I always tell people. I don't want you playing dot to dot. I don't want this. That is not what we do. Because that's not the way it's supposed to be. What we have is error. This is an error. You're probably off by a little bit. There's some error there. There's some error there. Either in, your measurement, how you read it, or something that you did. There's probably a little bit off in that you took those measurements in. So, for instance, this example says they took water depth versus the temperature of the water, and there is a relationship between that. And you can see, since this is going down to the right, that's going to be a negative relationship. In other words, as you go deeper, it gets colder, which that makes sense. Okay, so that's what's happening here. And then what they say is graph each of the data points and draw a line that best fits the data. Now, the line that best fits, see, a lot of times this is what people do. They pick the first dot and the last dot, and they draw a line in between that. And that is not the best data. Notice how many points are way off. That's off quite a ways, that's off quite a ways. But notice that if I draw it along their blue line, if I take their blue line and do that, there's only a couple of them that are off, and they're not off by a lot. So, and part of this is, it's not guesswork, but it's, you got to look at it and say, where's my best place that the line goes through and is the most closest to as many points as possible. A lot of times when you do it, you'll get an error. You'll get something that's way off over here. We don't want that. You know, we want to erase those kind of, we don't care about those. Those are outliers, and we don't want those. So what they did was they said, well, you know what, if I draw this line, you know, it's not quite on that, it's just a little bit above that point, kind of goes through that one, just a little bit below that one, maybe through that one, above, below. You know, there's probably, you know, look, there's 2 above the line, 2 below the line when I'm done. That's kind of the idea of the best fit line. You've got to use your own judgment to come out with those. And now they say, well, find the slope. Well, you know, occasionally, when you do a best fit line, especially when we do it in chemistry, we don't have a lot of points, there might be times where it goes through absolutely no points. But you could then pick out some points along the line. But it looks like this one actually crosses through a couple of points. So there's one, looks like 25.64. There's one there that's 35.58. And so once I have 2 points, I can now find the slope of that line. And so, let's close that ink layer. And if I go to the rest of this, I can see that if I've got my 2 points here, remember we're going to say x2 or y2 minus y1. So y2 is going to be 58 minus 64. x2 minus x1 is going to be 35 minus 25. I'm going to get negative 6 over 10, or negative 3/5 for my slope. So there's my slope. All I need now, I can put it in y equals mx plus b form, mx plus b form, if I know where it goes across the y-axis. So all I got to do is find the y-intercept. So I go up here. Where did it go across? Well, right about there. That looks like it's 79, let's say. And so I would say y equals negative 3/5 x plus 79. That would be my graph. And so what I can tell is, hey, if I know how deep I am in the water, I can estimate the temperature of the water using that equation right there. That's what, you know, those kind of things are helpful in order to do stuff like that. All right, I think you are ready to begin section 11.6.
Get it started. Let's get it started in here. Let's get it started. Let's get it started in here.